Alright, today we're going to show you what's happening when a capacitor charges and discharges, and this compass right here is going to help us see which direction the charge flow is going. We have two batteries, a light bulb, and a capacitor. That's not what a real capacitor looks like in a circuit, but this one's to make it easy for us. This over here is a voltmeter, which will tell us how many volts different parts of the circuit have. Well, one battery has, let me get down here where I can read it, roughly 1.5 volts. The other one has roughly 1.5 volts for a total of 3 volts. Well, let's start off by taking our capacitor and discharging it, which basically neutralizes the capacitor. Let me get these out of the way. So we're going to neutralize the capacitor by touching the two sides together. You probably already saw that move. So I'm letting electrons go to the positive side and it's neutralizing. We'll talk about that more later. Okay? Well, let's see what the voltage is of a discharged capacitor. And it is 0 volts, which makes sense. We've discharged it, so there's no voltage. There's nothing, the electrons and the protons are equal on both sides. Well, now let's connect the whole circuit. Okay, let's put a light bulb on, and we're going to pulse this. So watch what happens to that as I pulse it. Now you saw that it went this direction. Okay? Well, what's happening there? Obviously, electricity causes magnetic fields, or the compass wouldn't respond. What is happening underneath? Well, electrons go out of this part of the battery to the positive side. Electrons go from low voltage to high voltage. Or, the positive charges, which really don't move, we say they go from high voltage to low voltage. My right hand, pointing in the direction of the positive charge, kicks the compass that direction underneath. There it is. We kicked it a little bit that direction. You might say, but what happens on the other side of the wire? Well, my fingers come back around the other direction in a circular fashion. Let's show. Exactly as we predicted. So really it goes under, over, and around. But that's more about the right-hand rule in another video. We've charged up the capacitor a little bit. Let's find out what its voltage is. 0.5 volts. What happens if we do this for a longer time? We'll keep pulsing here. And every time I pulse, the compass, okay, now it's pointing north. Now it's deflected a little bit by the magnetic field of the current that's flowing. Now let's leave this on for a little while. And let's check the voltage, now that it's been on for a longer time. And instead of 0.5 volts, it reads 1.18, almost 1.2 volts. It's getting higher because the batteries are pulling electrons from the positive plate to the negative plate. Let's keep it charging now. Notice that as it charges, eventually the light bulb dims and eventually the light bulb will go out. Why does the light bulb go out? Because once we have pushed as many electrons to this side, or pulled electrons from the positive side, as strongly as we can, you can't fit any more on with this pressure. And the light bulb goes out because now that's no different than a break in the circuit. Well, what's our voltage now that the capacitor is fully charged? 2.6, okay, it's getting closer. Let's hold on for a little bit longer. Let's give it a couple more seconds here. The batteries again are pulling electrons from this side, or you could say they're pushing positives that way, but positives only move in some ionized gases or in some acids and so forth, where those are protons, but in solids like conductors, protons don't move. Let's see what our capacitor voltage is now. Really close to 3 volts. If I leave it on for a long time, it will go up to that 3 volts. We don't have that kind of time right now. So let's watch what happens though if I put this over on the light. Remember that it went that direction. Now let's watch what happens as I touch it straight to the light bulb. Now it's going the other way, which means the electricity must be flowing the other way. So if the positives are moving this way, it's kicking them underneath. So what's actually happening? Well, what's actually happening, there it is again, and let's check the voltage. We've just given up some electrons and our voltage is now at 2.2 volts. What's actually happening at this point is those electrons that were pushed onto this plate are flowing back to the positive plate, trying to neutralize the capacitor. And electrons flow from low voltage to high voltage. Let me discharge it a little while here. If you notice real carefully, the intensity of this light, or the brightness of the light, has dimmed a bit. And notice that our voltage is now down to 1.5, and let's get rid of some of that. That's getting quite a bit dimmer. And our voltage is now below 1, and will continue to go down. It's almost off, but let's see if we're actually out of voltage. There's still some there, but watch what happens though if I take this. Watch this right here as I discharge the capacitor. Now we're going to have a really, because we have a wire which is very low resistance. And we had a huge current very, very quickly, which brought our capacitor back to 0 volts.